Example 69.1, a quantity of ideal gas had initial pressure, volume, and temperature values of all that. Find the final temperature, the final pressure was all that. Okay, so what I don't want you to notice, we've already done these before, these ideal gas problems. In fact, there's one on our upcoming test, right?
Yeah.
Our formula is P1 V1 over T1 equals P2 V2 over T2. Up till now, these values have been pretty reasonable looking, like 100, 50, like that kind of stuff. Now all of a sudden we're getting these scientific notation looking things. They're not exactly scientific notation because our abscissas aren't between 1 and 10, but they got sort of that partial scientific notation form to it. So I could actually start substituting all that stuff in, but it makes a big mess in there. All right. So the recommendation here is to begin by solving the equation for T2. In other words, in variable form here, go ahead and get this to say T2 equals some equation, so then everything's right where it belongs. So then when I put all the stuff in, I just have to put it where it belongs. And then I'm going to use my skills from set 68, which is calculator usage, in order to type it in properly. So here's what it looks like. So I take this, and it says find the final temperature. Final temperature is T2. So if I cross multiply this, I get P1 V1 T2 equals P2 V2 T1. Simple cross multiply there, right? Pay attention to the subscripts. So make sure you make them subscripts. I see it quite often. People will put T2 as T squared instead of T sub 2, but they're all subscripted variables here, so put them below. And if I want to get T2 equals, I just got to divide both sides by P1 V1. And just like that, I've got a formula for T sub 2. Okay? I can do that for any one of the 6 variables. You cross multiply, you always get this. And whichever variable you want, just divide by the stuff being multiplied. So if I wanted V2, for example, divide this side by P2 T1, and you got what V2 is. So you have the ability to get any one of those variables equal to everything else. And if we take a look in our stuff, 40 times 10 to the 4th atmospheres is the initial pressure. That's P sub 1. And 0.03 times 10 to the negative 6 cubic centimeters, that's a volume, that's V sub 1. And 700 times 10 to the 4th Kelvin, that's T sub 1. And I'm running out of colors. 0.0004 times 10 to the 15th atmospheres is P sub 2. It's not a good color. I was kind of hoping that wouldn't happen. And let's just, I'm going to do this.
Mix them.
The light red or something.
I'm going to do a circle. There's V sub 2. There we go. All right.
Oh my.
So all the information we need is right there in our sheet. But again, instead of having it all put in here and then to cross multiply with all those scientific notation numbers, if I go ahead and get that expression, I'm ready to go. So I end up with T sub 2 is equal to, big fraction bar, P sub 2 is the 0.0004 times 10 to the 15th. And V sub 2 is 0.015 times 10 to the negative 14th. And T sub 1 is 700 times 10 to the 4th. And P sub 1 is 40 times 10 to the 4th. And T sub 1 is V sub 1, sorry, V sub 1 is 0.0003 times 10 to the negative 6th. We have 2 options for doing this. Let me go through the 2 options for you and see which one you prefer. Option 1, type it in. Okay? If you go with option 1, be careful, there's a product on the bottom. You must encase the bottom product in parentheses. The top does not have to be put in parentheses. So if I do option 1, just type in what I'm looking at. It looks like this. 0.0004 second comma 15 times 0.015 second comma negative 14 times 700 second comma 4 divided by, now parentheses, because I want that product to be multiplied before the division happens, 40 second comma 4 times 0.0003 second comma negative 6 in parentheses. And that's option 1. Hit enter, you get the answer. 3,500,000 kelvins. That's hot. Probably cause a flesh burn, I'm guessing.
I think so.
Something in the 3rd, 4th, 5th degree range. I think 3rd's the worst you get. That'd be more like a 7th degree, yeah, 7th degree flesh burn. All right, anyway. Option 2 is to just type in the top, hit equals 0.0004 second comma 15 times 0.015 second comma negative 14 times 700 second comma 4 equals, that's the top, 420. And then you type in the bottom 40 second comma 4 times 0.0003 second comma negative 6. Hit equals again. That's 1.2 e negative 4. So times 10 to the negative 4th. So get the top answer, get the bottom answer, and then type in the top divided by the bottom. Same answer. All right. Take your pick. This is for the more cautious student. I want to make sure I type it in correctly. You can actually see the entire thing there, the entire thing there. When you type the whole thing in, it kind of goes off screen. So if you type it in just the top equals, just the bottom equals, you can see the top's typed in right, see the bottom's typed in right, see your answers. And then you get top answer, bottom answer, divide. There's no parentheses necessary. For the student that's more comfortable with calculator usage and they know I didn't type anything in wrong, I never do, then by all means go ahead and do that if you want, but just know that if you get a wrong answer, usually off by a power of 10. You'll have to zero off, you did something like that wrong. But I personally like this method myself. I like the top answer, bottom answer, then divide. I like to see on the screen that I'm typing everything in. But again, you take your pick. They both work as long as you type it in correctly. If you go with option 1 though, I would verify as I type a number in. Type a number in, look to see that it's there, because again, they do go off screen. And just to verify that it's all typed in correctly, the one thing that's going to get you the wrong answer on these.